Namaste everyone. Hope all of you are well. My humble request to each and every student to stay at home, stay safe because already you are seeing the number of corona positive cases are increasing day per day. So from my side and my organization side, we are having an humble request to all of you to stay at home, stay safe, stay healthy. Except these all, we are moving towards our education also. I know it's very difficult to give an interaction in online, but then also we are trying our level best to give you online class interactions. So let's start. Today I'm going to discuss about few of the molecular orbital theories diagram. As already I had informed you about MOT in the previous video, all of you have seen in the chemical bonding chapter. Molecular orbital theory, in which I have already described you about in the previous video. You can go and you can search molecular orbital theory by Sonu Sir. You will get how to draw the molecular orbital diagrams. What we have to calculate in this theory is bond order, the number of bonds, and the special things about the bonding electrons and anti-bonding electrons. If I talk about B2, C2, N2, in which the number of electrons are less than 14, then already I have said you how the 2px, 2py energy is less than 2pz. Just remember that for B2, C2 and N2 means the number of electrons are less than and equal to 40. Sorry, it's greater than I have written. Number of electrons are less than and equal to 40 means, how you will understand that here in the boron atomic number 5, so total 10 electrons, in carbon 12 electrons, nitrogen 14 electrons. So here I have already said you about the p orientations, that how do p orientations energy splits and how do they separate their energy levels. You can see here that 2px and 2py bonding electrons and anti-bonding electrons. That's the main reason what I want to say here. This is the 2px, 2py and 2pz. Both the energy of 2px and 2py are equal. So here 2px and 2py and upside 2pz. These are sigma bondings and this is pi bonding. So here the energy level increases. Similarly here, if I talk about, these are the sigma stars. What are this? Sigma star. This is 2px, 2py and this is 2pz. So this is pi star. Star means here anti-bonding and this is bonding electrons. Here 2px, 2py, 2pz. Just suppose these are the p orbital diagrams. Similarly, we have to draw our s level orbitals diagram, 2s2. So nothing to worry about. Just draw the energy level diagrams. And you can see here how we are drawing the diagrams. This is 2s2, 2s2 electrons. So both the electrons will be here, here 2 electrons. So these are the sigma bonding, this is anti-sigma, means non-bonding electron. Similarly, 1s2 electrons will be there. One has 2 electrons, sigma bonding, anti-sigma bonding, right? Energy increases. As already I have said you, this diagram is drawn in your NCERT textbook also, you can see. If I talk about boron, then you know very well boron's atomic number is 5. There are 2 boron, so boron 5, 1s2, 2s2, 2p1, right? Similarly, this also 1s2, 2s2, 2p1. So here see 1s2 2 electrons, 2s2 2 electrons, 2p1, 2p1. So here 1 electron in 2px and another electron in 2p1. So if I want to calculate here the bond order of this B2, now of the B2, okay, B2 atom molecule is B2, as you can see, 1s2 of this boron and 1s2 of this boron, bonding electrons and anti-bonding electrons. Similarly, 2s2 bonding electrons and 2s2 anti-bonding electrons, 2p1 and 2p1, total 2p1, 2p1, here 2p1, 2p1. Now, if I talk about the bond order, anybody will ask you what is bond order? Bond order means the number of bonds participated between the 2 atoms. So here it is number of bonding electrons, minus number of anti-bonding electrons, upon 2, right? So number of bonding electrons you have to count, sigma here 2, here 2, 2 to 4 and 2 6. Number of bonding electrons is 6. And what's about the number of anti-bonding? 2 here anti-bonding, 2 here anti-bonding and 0 here. So 2 to 4, 6 minus 4 upon 2, that is 2 upon 2, that is equal to 1. So between boron and boron, there will be single bond. How many bonds? Single bonds. Now similarly, they will ask you about the magnetic properties, means magnetic nature. So magnetic moment, it's paramagnetic or diamagnetic, it is under root n into n plus 2 bm, where n is equal to number of unpaired electrons. Here you can see the number of unpaired electrons. Here in 1s2 and 2s2, all the atoms are in paired, but here you can see one electron is in 2px and another electron is in a 2py. So there are 2 number of unpaired electrons. So 2 into 2 plus 2 bm, 2 plus 2 4, 4 plus 2 under root 8, that is equal to 2.9 something, 2.9 or anything, 2.9 bm you can write. Okay, so here you can see, if you want to, under root 8 means what? 2 root 2, and 2 root 2 means what? 2.414, 2 into 1.414, so 2.282. This is the real value, 2.282 bm. And what is the magnetic nature? Since there is an unpaired electron, so it is paramagnetic in nature. Hence, paramagnetic in nature. So as you have seen about B2, similarly if I talk about the C2 means 2p2, total 4 electrons, 1, 2, 3, 4. Since both are paired, so the bonding electrons 2 to 4 to 6 to 8. 8 minus 4 upon 2, 4 by 2 means 2, carbon-carbon double bond. So if you want to calculate, then just I am showing you about, just if you want to calculate C2 molecules number of bonds or bond order. So just let's suppose here, so you can see here, if I talk about the carbon, means 1 carbon, atomic number 6, 1s2, 2s2, 2p2. Similarly, another carbon also 1s2, 2s2, 2p2, right? So here you can see 1s2, 2s2 is right. 2p2 means 2 electrons in both the p orbitals. So 1, 2, 3, 4, right? So here you can see the bond order of this carbon will be, bond order is equal to bonding electrons Nb minus Na by 2. Nb means how many electrons? Bonding 2 to 4 to 6 to 8. Anti-bonding 2 plus 2, 4. 8 minus 4 by 2, that is equal to 4 by 2, that is equal to 2. So carbon-carbon will have double bond, right? Carbon-carbon will have double bond. Now question is what? It is paramagnetic or diamagnetic? Since you can't see here anywhere the unpaired electrons, since there is mu m is equal to 0, that's why it's diamagnetic in nature. What is it? Diamagnetic in nature. It is about C2, okay? These all the things is about C2. Earlier I have described about B2. Now can you describe yourself about the N2? In the N2 means 14 electrons, 1s2, 2s2, 2p3. So total here 2p3, 2p3. 2p3, 2p3 means here also 3 electrons, here also 3 electrons. So 2p3, 1, 2, 3, 4, 5, 6 total. Here 6 to 8 to 10. Bonding electrons 10, anti-bonding electrons 4. 10 minus 4 by 2, 6 by 2. So nitrogen will have triple bond. Bond order will be 3. So nitrogen will have triple bond. And since all the electrons are paired, so it will have diamagnetic in nature. So as you have seen here, B2, C2 and N2. All the 3 atoms molecular orbital diagram, bond order and the main magnetic properties, that is magnetic moment, mu m is equal to under root n into n plus 2 bm. So I hope all of you have understand about this number of electrons which is less than and equal to 14. What's about the greater than 40? If you want to take a screenshot, you can take a screenshot. Now I will move ahead for the oxygen and fluorine. And next I will tell you about the hetero-diatomic molecule. Now I am talking about if n is greater than 40, means number of electrons especially in the O2, F2, right? Oxygen, fluorine. Now let us discuss about these molecules, how their orbital diagrams will be drawn, right? Now just suppose about O2, oxygen atom. In the O2 there are 2 oxygen atomic number 8, 1s2, 2s2, 2p4. Another oxygen atom also, 1s2, 2s2, 2p4. So here 1s2, 2s2 is there are total 4 electrons. Here you can see 1, 2, 3, 4, 5, 6, 7, 8. Right? Now question you can ask me, sir, here I just want to tell you, if there will be greater than 40, then anti-pi bonding will be less. Why? Because here as the electron starts pairing, remember this word, as the electron starts pairing. So here the sigma electrons, 2pz electrons has less energy and it comes down. Now you can ask me, sir, how is this possible? How is this possible? Here there will be only changing in 2pz electrons. This 2pz electrons will come down and rest everything is going to remain same. Means here there will be 2pz and here 2px and 2py. Got it? Now you can ask me, sir, why these things happen? Because as the electron starts pairing in p orientation, you can see here the p orbital starts pairing. So that's why here the sigma bond energy level comes down. So there are 1, 2, 3, 4, 5, 6, 7, 8 electrons. So this is your sigma and this is your pi bonding. So there are total 8 electrons, 1, 2, 3, 4, 5, 6, 7, 8. Remember? So here also you can ask, sir, why not in anti-bonding this pi star come down or sigma star come out? So these are the pi, sorry here. These are pi star and these are sigma. Okay? So here you can ask me, sir, why don't this pi goes up It should go or not? You can ask me. I'm telling you to do. Here the energy level increases in this order. You have to just remember, in the p orbital, if n is less than and equal to 14, then this sigma will be up and this 2px, 2py will be down. And when the n is greater than 14, means from 15th electron or 16th electron, then this energy, means sigma energy, comes down and pi energy goes up. Why they go up? Because the pairing starts. So as you have seen here in the oxygen atoms, directly if I talk about, so here bond order is equal to Np minus Na by 2. Number of bonding electrons 2 to 4 to 6 to 8 to 10. Number of anti-bonding electrons 2 to 4 to 6. 10 minus 6 by 2, that is 4 by 2, that is equal to 2. So oxygen will have double. If I talk about the magnetic moment, there are two unpaired electrons. You can see here two unpaired electrons. So the magnetic moment value will be 2 into 2 plus 2 bm, that is equal to under root 8 bm. Under root 8 bm, 2 root 2 bm. Hence paramagnetic in nature. Hence paramagnetic in nature. If anybody asks you why paramagnetic, because there are two unpaired electrons, so that's why there are paramagnetic in nature. If it would have no pair, means always there will be a paired, then there will be a diamagnetic in nature. Since it is having two unpaired electrons, so that's why paramagnetic in nature. So just take a click. After that we'll discuss about fluorine. Now let's talk about fluorine. Just talk about fluorine. Fluorine means F2, fluorine atomic number 9, 1s2, 2s2, 2p5. Similarly this 1s2, 2s2, 2p5. So here 1s2, 2s2, 2p5 is total 10 electrons. 2p5, 2p5, 2 to 4 to 6, 7, 8, 9, 10. Okay? So bond order will be, bonding electrons 2 to 4 and 6, 10. Non-bonding electrons 2 to 4 to 6 to 8, 10 minus 8 by 2, 2 by 2, that is equal to 1. So fluorine will have single bond. Fluorine will have single bond. What's about the magnetic moment? Magnetic moment, you can see all the electrons are paired. So n value will be 0, with 0 into 0 plus 2, that is equal to 0, means 0 bm. And what will be the magnetic in nature? Since there is no paired electrons, none of the electrons are in pairs, so that will be diamagnetic in nature. What will be it? Diamagnetic in nature. Okay? Now, after understanding this concept, this was the Homo. This was Homo. Now I will talk about the hetero. If in the case of hetero, like CN, carbon 6, nitrogen 7, 6, 7, 13, nitrogen and oxygen, carbon and oxygen. So now, in this case, what will be there if the number of electrons is greater than 14 or number of electrons is lesser than 14? So what will be the arrangement of this sigma and pi electrons? Do it will remain the same as it is in the homonuclear atom or in the heteronuclear atom? So just see this, take a click. Now I will describe you about homo and heteronuclear atoms. Now, in the case of heteronuclear atoms, this was the homodiatomic molecules. Now heterodiatomic molecules. Before that, I would like to tell you about the neon also. So 2p6, all the electrons will be fulfilled. So here bonding electrons 2 to 4 and 6, 10 minus 10 by 0. So there will be no bonding between the neon and neon. Now let's discuss about the heteronuclear atoms. In the heteronuclear atoms, as I have said you, if it will be greater than and less than 14, what the phenomenon will occur about the energy. See, remember dear students, there will be no changing in orbitals, as this orbital will be always for n is greater than 14. Either they are homonuclear or heteronuclear. If it is less than 14 or equal to 14, then what you will do, you have to just put this pi electrons 2px and 2py down, nothing else. What you have to do? 2px and 2py down, nothing else. When the number of electrons is less than 14 or equal to 14, then the pi electrons will be down. So let's give you an example and clarify the doubts that you will be able to understand after giving the examples, right? So let's start. Here, can you tell me any of the diatomic which is having greater than or less than 14? So I can clear your all the doubts. It's very easy, I hope all of you know also. So just suppose, here I'm erasing this number of bonds and everything. Now, just take any diatomic, CN, ON, OC, whatever the bonds you like, any bonds, just remember this value n is greater than and n is less than. In n is greater than 14, the same arrangement. If it is less than, then pi electrons will come down. Just suppose cyanide, you know CNI, yes? C and cyanide. Just suppose in cyanide, what you will do? There is a carbon whose atomic number is 6 and nitrogen atomic number is 7. 6 plus 7, 13. Then what will happen? Since 13 is less than 14, so this pi electrons will come down. What will happen? The pi electrons will come down. And sigma electron will go up, right? So this is pi, and this is sigma. Now just suppose the atomic number of carbon 6, 1s2, 2s2, 2p2, and about the nitrogen 1s2, 2s2, 2p3. So here 1s2, 2s2 both same, 2p2 and 2p3, 2p2 and 2p3. This is the nitrogen configuration, this is the carbon. So total number of electrons 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. So number of bonding electrons you can see 2, 2, 4, 2, 6, 2, 8, 1, 9. How many bonding electrons? In cyanide I am talking about C and N. You can see here in C and N. Just remember these words. Cyanide less than 14. Less than 14 means pi electrons will come down. Pi electrons down means here you can see 2px, 2py and 2pz will go up. So here total number of electrons are 2p2 and 2p3. Total 5 electrons are there. 1, 2, 3, 4 and 5th electron. So 2 to 4 and 5, 9 electrons are there in bonding. In anti-bonding 2 plus 2, 4 bond. 9 minus 4 by 2, that is 5 by 2. That is in the fraction 2.5 bonds. How you will represent this 2.5 bonds? Right? How you will represent this 2.5 bonds? Very easy. 2 bonds you have to put and 3 times x. This means half bond. Remember, this triple x means half bond. 3 times you have to represent this x means half bond. So here it's not a valence bond theory, it is molecular orbital theory. Here the bond can be in fraction also. This is the new thing which you learn in this molecular orbital theory, right? So here, as you have seen in the cyanide, the number of bonds is 2.5, 5 by 2. So here if I want to calculate the magnetic moment, what I will do here, just I want to find the number of unpaired electrons. Here 1. So 1 means 1 into 1 plus 2. So under root 3. So that will be under root 3 bm and paramagnetic in nature. Got it? So what you have to remember, you have to just remember the number of electrons is greater than or less than 14. Number of electrons is greater than or less than 14. Don't forget this concept. Either I am talking about the homonuclear atom, heteronuclear atom or any types of nuclear atom, you have to just remember about that, the sigma bonding and pi bonding. anti-sigma bonding and anti-pi bonding. There will be only changes in the bonding electrons of 2p orbitals when the number of electrons is lesser than 14, pi electrons will be down. When the number of electrons is greater than 14, then pi electrons will be up. I hope all of you have understand. Is there any doubt in this concept? Can you find any of the diatomic, either homo or hetero? If you are having doubt, then you can tell me, I can clear your doubt. Yeah, one more thing. Sometimes the students are having more doubt in the homonuclear diatomic heavy charges. Still now, just cyanide, O, NO, you can also calculate. Just suppose about the NO. N and O. How many electrons? 7 and 8, 15, greater than 14. So what will be there? Sigma electron will be down and pi electrons will be up. Sigma electron down, pi electrons will be up. Right? Right. So here, just suppose nitrogen electronic configuration 1s2, 2s2, 2p3, and oxygen electronic configuration 1s2, 2s2, 2p4. So total 7 electrons in the p orbital 1, 2, 3, 1, 2, 3, 4. So 1, 2, 3, 4, 5, 6, and this 7th electron. 1 will go up. So total number of bonding electrons 6 plus 4, 10. Anti-bonding electrons 2 to 4, 1, 5. 10 minus 5 by 2. Right? 10 minus 2 to 4 and 6, 10 minus 5 by 2, that is 5 by 2. Again here N and O will have how many bonds? 2.5 bonds. Here half bond is also considered. So remember, dear students, either in the case of N is greater than 14 or N is less than 14, the same homo or heterodiatomic molecules, molecular orbital diagram will be the same, and I hope all of you can calculate. What's about the charges? If I talk about O2 plus, then it's also very easy. O2 plus means what, you know? In one oxygen it is oxygen, and in another oxygen it is oxygen plus. O2 plus means, what is the meaning of O2 plus? One is oxygen, another is oxygen plus. Here 8 electrons, here 8, here 7, 1 S2, 2 S2, 2p4, and here 1 S2, 2 S2, 2p3, because one electron has been removed. So same, you can see 2p3, 2p4. The here oxygen means, if anyone will ask you what will be the bond order of O2 plus bond order will be 2.5 bond. Got it? Have you understand or not? This is the main concept of molecular orbital theory. I hope all of you have understand about this concept. If you are having any doubt related this concept, then you can put your doubt into the drop the doubt into the comment box section. Next we'll move towards, after clearing this doubt, means whole molecular orbital theory is done, either of any atom. I am giving you some of the atoms by which you have to calculate. Draw the molecular orbital diagram of first C2 plus, second NO plus, third CN minus, fourth O2 2 minus, fifth carbon and fluorine, carbofluoride, CF. Okay, so this 5 diatomic, heterodiatomic molecular orbital diagram, you have to also consider the bond order. What is the bond order? And also you have to consider the magnetic nature. It is paramagnetic or diamagnetic, and what will be the magnetic mu m value. Okay, so for all these 5 diatomic, heterodiatomic molecules, heterodiatomic chargeable molecules, you have to consider all these 5 atoms molecular orbital diagram. This is your homework, write in your notebook, and I hope you can consider these 5 atoms molecular orbital diagram. Now I will start the new topic called hydrogen bonding. So let's discuss about hydrogen bonding, our new topic. What is hydrogen bonding, why hydrogen bonding occurs, and how many types of hydrogen bonding. So first of all, you all know covalent bond. What is covalent bond? The force of attraction between the two atoms, and both the atoms complete their last cell duet or octet, nearest inert gas configuration, you can say, by mutual sharing of electrons, right? Now our new topic is hydrogen bonding. All of you can give in a notebook our new topic name, hydrogen bonding. Hydrogen bonding. First of all, what is this hydrogen bonding? Why hydrogen bonding and how many types of hydrogen bonding? So let me first of all describe you about hydrogen bonding. What is hydrogen bonding? Hydrogen bonding occurs between the two electronegative atoms. Just suppose if I talk about hydrogen fluoride, right? Hydrogen fluoride, HF bond, hydrogen fluoride. Just suppose these are the hydrogen fluoride bonds. You can see here this hydrogen and fluorine, hydrogen and fluorine. What is this? Fluorine is highly electronegative element. Fluorine is highly electronegative element. Since this fluorine is highly electronegative element, so what this fluorine will do? Fluorine will attract this another hydrogen atom with this fluorine atom. Okay? What I mean to say, this was HF one molecule, this was HF another molecule. Because of highly electronegative element, because of highly electronegative elements, this fluorine atom attract this hydrogen atom towards itself. As this fluorine atom attracts this hydrogen atom towards itself, so then there is a formation of hydrogen bonding. Means when two atoms are there, right? Two atoms, just suppose here you can see here HF, any atoms you can take, not only HF, just remember highly electronegative. What are the highly electronegative elements? Fluorine, oxygen, nitrogen, chlorine, these are the means. The three conditions are there. The atomic size should be small. Not about the chlorine. Atomic size should be the same. You can tell me, sir, will hydrogen bonding occur in HCl? Then I'm directly telling you no. Why? Because the chlorine atomic size is greater. That's why there will be no formation of hydrogen bonding in HCl. There will be formation in HF, there will be formation in H2O, there will be formation in NH2. Right? So here you can see the fluorine atomic size is very much small. Here fluorine atomic size is very much small, but the fluorine has highly electronegative value. Its electronegativity value is 4. And what is the electronegativity value of hydrogen? 2.1. So now here this hydrogen atom comes towards this fluorine atom. Why it comes? Its atomic size is small, highly electronegative element. So that's why this hydrogen atom attracts towards itself. Now question is, how will be the shape? You can ask me, sir, how will be the shape of this H2F or HF? So first of all, I would like to say you, fluorine is highly electronegative element. Highly electronegative element. Right? So fluorine will be here. One electrons will be attached like this. Right? Fluorine will be here. Now, if this hydrogen atom is there, and another fluorine atom is attached with this hydrogen atom. Just suppose, means these both are the bonds of HF. This is HF bond and this is HF bond. Now, this both the atoms will attract each other because of the fluorine highly electronegative elements. This fluorine will attract this hydrogen atom towards itself, and then there will be a formation of hydrogen bonding. Then there will be a formation of hydrogen bonding. What will be the bond length here, you know? What will be the bond length of HF? It is 1.55 angstrom. Remember here, yes, there is a formation. Don't understand if I have just represented by a dot, then you will suppose that, sir, there is a no hydrogen bond. Here it is a hydrogen bonding. So that's why I have represented as a dot. You can see here 1.55 angstrom is the bond length. If you want to calculate the bond angle between the HF and HF, there is a 116 degree. Here you can see, just suppose here one fluorine, and you want to calculate the bond length between the HF, there is a 116 degree bond angle. How much? 116 degree. So hydrogen bond is formed between the two atoms or two molecules when that both the atoms are highly electronegative. Means it can occur between the oxygen, hydrogen also. H2O bond is there. Just suppose this is H2O. Okay, what is this? H2O. And here also just suppose oxygen, means same diatomic I have to represent. I don't have to represent any other thing. I have to just represent here hydrogen, oxygen, just suppose this. So here between these oxygen there will be also hydrogen bonding. Why? Already I have said you it is a highly electronegative atoms, and because of the small atomic size. If you want to understand the concept, just listen what I am saying you about the hydrogen bonding. Remember this concept about the hydrogen bonding. Whatever I speak, just try to write in your notebook. Hydrogen atom is bonded to a highly electronegative element by a covalent bond. The bond pair of electron is displaced towards the electronegative atom. When solitary electron of hydrogen atom lies away from it, the nucleus gets exposed and behave as a bare proton. Such a bare hydrogen nucleus exerts a electrostatic attraction force on the electronegative atom to the adjacent molecules. This interaction between the hydrogen atom of one of the molecule and electronegative of the other atoms is referred to the hydrogen bonding. As already I have said you here, so there is a force of attraction between the two molecules, between the highly electron. It is represented as this dot dot dot. This bond is called hydrogen bonding. There is a formation of hydrogen bonding. What are the criteria of this hydrogen bonding? As already I have said you, the conditions for hydrogen bonding is hydrogen atom should be bonded to highly electronegative atom such as fluorine, oxygen and nitrogen, which has highly electronegative. If anybody will ask you whose electronegativity value is greater, you know very well, fluorine has the highest electronegativity, after fluorine oxygen and then nitrogen. The size of the electronegative atom should be small. If the size of the electronegative atoms will be large, then there will be no formation hydrogen bonding. Means HF is greater than HO is greater than HN. So as you have seen these three, highly electronegative atom, atomic size also small. There will be no hydrogen bonding in HCl. Got it? So here you have seen the examples of hydrogen bonding. Now the last concept of this hydrogen bonding, how many types of hydrogen bonding? There are two types of hydrogen bonding. How many types of hydrogen bonding? Two types of hydrogen bonding. Which hydrogen bonding? The two types of hydrogen bonding are intermolecular hydrogen bonding and intramolecular hydrogen bonding. As right now I have told you about the intermolecular hydrogen bonding. How many types of hydrogen bonding? You can write in your notebook also. There are two types of hydrogen bonding. Hydrogen bonding. First, inter. Inter means, as we have seen, the highly electronegative atoms interact towards itself. So that's why it's known as intermolecular hydrogen bonding. Intermolecular hydrogen bonding. And next one is intramolecular hydrogen bonding. Intramolecular. What do you understand by inter and intra? Intermolecular hydrogen bonding means HF, HN, HO. These three are intermolecular hydrogen bonding. But if I talk about the other atoms, here you have seen these all the atoms are attracted by the, you can see H2O, hydrogen bonding occurs with another H2O, HF with another HF, NH3 with another NH3. So here there is an intermolecular hydrogen bonding. But what's about if the one atom interacts with the different highly electronegative atoms? If I talk about orthonitrophenol, have you heard about the orthonitrophenol? You may have not heard. I'm telling you, it's very easy. Orthonitro. First of all, draw a phenol structure, or you can just suppose this is a benzene. You know very well. In this benzene, just suppose this. Remember this formula: orthonitrophenol. Here nitrogen, here oxygen. Orthonitro, and now I will draw phenol. Means here and here. Oxygen, oxygen and hydrogen. Now you tell me, here is also oxygen, here is also oxygen. So between this oxygen and hydrogen, this bond will be known as intramolecular hydrogen bonding. Intramolecular hydrogen bonding. What is the meaning of this intramolecular hydrogen bonding? As already I have said you about the intermolecular hydrogen bonding, the reasons, the conditions: atomic size should be small, and the second, it would have highly electronegative atoms. Here also the highly electronegative atoms. But what you have seen here, have you ever noticed that what is the difference between here in the intra and intermolecular hydrogen bonding? If you have NCERT, then in the NCERT textbook it is written, it is formed by the hydrogen atom is in the between of two highly electronegative atoms. It is in the between of two highly electronegative atoms. If you are not understanding the concept, just I am telling you, just remember, inter means hydrogen atom will be not in between. Here the two highly electronegative HF. So here you are seeing between the two hydrogen atom, one single highly electronegative element is there. So that is called intramolecular hydrogen bond. And here you can see two oxygen highly electronegative element is there, and between that hydrogen is there. So this is called intramolecular hydrogen bond. So remember, between the inter and intermolecular hydrogen bonding, it is formed by the two different molecules of the same or different compound. Remember this word, of the same or different compound. Whenever I discuss about the hydrogen bonding, you must remember these two types of bonding, and this same or different compound, as I have said, your HF. So where the hydrogen bond is formed? Hydrogen is formed between this fluorine and hydrogen. So here what you see, H and H, fluorine is in between, and here as well in the orthonitrophenol, you can see oxygen is there and hydrogen is in between, right? So this is intramolecular hydrogen bonding, and this is intermolecular hydrogen bonding. Hydrogen bonding is occurred due to the highly electronegative atoms and short atomic size. So this was our full chemical bonding chapter. If you have any doubt related to this whole chapter, then you can drop your doubt, you can call me, you can ask me. Definitely anything or any doubt you are having, you can just go through my YouTube channel. You can open my email ID is also there. You can put your doubts into the email also. If you don't want to put in the YouTube, you can drop your doubt on the email. I will definitely solve in the next video. That was our whole chemical bonding chapter. Hope all of you have enjoyed this chapter. If you are having a doubt, then please share your doubt. That's all for today. Thank you very much. And one more thing, if you don't want to like the channel, if you don't want to subscribe the channel, there is no forced to you that you should like and subscribe. If you don't want to like and subscribe, you should not like, you should subscribe. The main reason, if you like the video, then only you like or subscribe. Otherwise, no need to like and subscribe. That's all. Thank you very much.